Alright, this is the blueprint reading, EET 109, electrical blueprint reading. We're going to go over blueprint reading fundamental symbols. We're just going to go pages 1 and 2. Okay. Blueprint reading fundamentals, page 1. We'll start at the top with W. W is watts. And watts is basically the same thing as volt amps right under it. So volt amps or watts, either one is interchangeable. That is volts times amps. That's the power that we use. That's the usage of it. It's how we measure it. E is voltage. Voltage is the electromotive force that pushes the amps. And I is amps. Amps is the current, the flow of electricity. The next little symbol right there is a resistor. We measure resistor in ohms. If you'll remember that later, we got voltage, amps, ohms. A capacitor, inductor, direct current, and alternating current. Direct current is a battery. You got a positive and a negative. The electricity flows from one side to the other. Alternating current, AC power, is a little different. It has no battery. It has a generator that produces the electricity, and you got the sine waves that go up and down, and they're causing it to alternate back and forth. When we read the voltage on alternating current, most of our meters are going to read 120 volts. But in America, we're on a 60 hertz cycle. So 60 times a second, the power is going on and off. That's why when you get far away from a city, you can see the lights kind of flickering in the distance. That's being able to see the alternating current at a distance, see the fluctuating of the light from a distance. The next one is a 3-0 with a slash through it. That's three-phase power. That means you got 3 hot wires coming into the system. The next one's a single phase. Now, a lot of people get confused, but a single phase does not mean it just has 1 hot wire. It can be hot wire and a neutral, or 2 hot wires and still single phase. 3-phase has 3 hot wires and still can have a neutral. RMS is root mean squared. OC is overcurrent. This is a breaker symbol. How it breaks the two with a little rounded part. It's a breaker. This is a fuse. Peak voltage, average voltage. These are all right in here, things that you would see on generic symbols that read your definitions here. Volts, electromotive force, difference in potential. Inverter, inverts DC, changes to AC. Path is a wire or conductor. That's the path that goes back to wherever we're going. Peak voltage, that's the highest point of the cycle. That's your peak. The average is your peak times the 6.37. That gives you a DC output. Root mean squared is 7.707 of the peak value. Overload is a heater, resettable after temp is decreased. So what happens on an overload is it gets too hot, it kicks out, and you got to let it cool back down, and then you can press the overload and reset it. Most overloads are on motors. When the motor gets too hot due to a load or something, the heater will kick out. You wait a few minutes, you can reset it, and the motor will start back up. ELI stands for induction. I stands for capacitance. XL, inductive reactant. XC, capacitive reactance. R is resistance, opposition to the flow. we measure the resistance in ohms. So here's the ohm symbol right here. PF is your power factor. A lot of motors and transformers have power factors to them. The closer to 1 the power factor is, the better. You don't lose any power, you don't have any loss of power, the better it is. Z is impedance. And here's the pie charts and the ear chart. E equals I times R. You can flip that. I equals E divided by R. R can also be R is E divided by I. That's what all this stands for. On the pi, it's P equals I times E. I equals P divided by E. And E equals P divided by I. If you look at it over here, you got the P, E, and I. So if I got I and I got an I and a P and I need the E, I can take P divided by I and it equals the E. Or I can take I times E and get the P. That's what this is saying. Now remember, P is watts, I is amps, E is voltage. And then R is resistance right here. That's how you read this chart. So these two charts are